Git repositories are not the only thing that GitHub offers. There are many others, and today we are not going to focus on Git itself, we are going to focus on GitHub Actions as a potential solution for all our CI/CD needs, for our pipelines or workflows. By the way, I recently published a video about continuous integration, continuous delivery, deployment, testing. You might want to check it out. It is a sort of introduction to the practical part we are going to explore today. And that practical part is about running CI or CD processes using GitHub Actions. We're going to do a hands-on exploration of GitHub Actions, and we are going to do that by creating two pipelines. The first one will be triggered whenever we create a pull request or whenever we update, whenever we do any of the operations we can do with pull requests. We will build container images and push them to registry. We will create a temporary cluster where we can deploy that release candidate. And to create that temporary cluster, which by the way will be completely free, no charge whatsoever. Anyways, to create that cluster, we will use K3D. Now, if you're not familiar with K3D, there's another shameless plug. I created a video about that. It's above my head, probably the link somewhere, or in the description. Go to the description probably. Finally, once we create a temporary cluster, we are going to deploy our release candidate to that cluster, and then we are going to run some tests, and then we're finished. And once we're finished, everything we created will be destroyed, meaning the cluster and everything else. The second pipeline will be triggered whenever we push some changes to the main line. In most of the cases, those changes will be pushed by us merging that pull request to the main line. And that action of merging a pull request to the main line will, in this context at least, mean that we are ready to deploy that something to production. So whenever we push to the mainline or merge a pull request to the mainline, which is the same thing, we're going to build a final release, we're going to push it to the registry, we are going to deploy it to our production cluster, and do whatever else we might need to do. Effectively, those two pipelines will be a simplified version of continuous delivery, and it is continuous delivery instead of continuous deployment because the action of merging the pull request to the mainline means that we are ready, that we approved deployment of a new release to production. It is not going to be a very complicated scenario. I'm not going to put all the possible permutations of what we might want to do when doing continuous delivery, but to simplify the one, it will be just enough for you to understand how GitHub Actions work and how in general terms we might want to approach continuous delivery. So let's explore through practical demo GitHub Actions in 20 minutes or less. Before I started recording this session, I created a cluster, I forked a repository with sample manifests, and I created a couple of secrets in that forked repo. Now for creating secrets, I used GitHub CLI. If you're not familiar with GitHub CLI, the link is above my head. Check it out, so make sure that you're familiar with it. And the instructions how to do everything I already did and everything that I am about to do are in a gist. And the link to the gist is in the description of this video. So if you want to follow along or if you want to reproduce what I'm doing, check out the link to the gist. You will find all the instructions how to copy and paste everything over there. Let's say that we want to work on a new feature and we want to see how we can take that feature from development to production. The first thing we would almost always do is create a new branch for that feature, at least if you're using feature branches approach to our branching strategy, I guess. Yes. Anyways, git checkout -b my feature. Now I'm going to simulate development by writing some silly files. So let's say something.txt, and I'm going to say I am too lazy to write real code today, right? I'm simulating development just by making a silly change to the repo. After a couple of hours or maybe a full day of development, I would add those files, I would commit those files, a silly feature, and I would push those files. Now I actually need to set upstream stream origin my feature. I created a branch, I made changes to the code, I pushed those changes to the branch. And now comes the moment to create a pull request, and from there on, everything will be automated through GitHub Actions, except merging the pull request to the main line. This repository already has Docker file. Here it is. Now, to accomplish what I already promised that we will accomplish, we need a pipeline, and that pipeline is already created. I did it in advance, and it is located in GitHub, and then workflows, and then pr.yaml. Now, github.github/workflows is the default location that GitHub will use to deduce whether there are any actions it should perform. It will run all the actions that it can, or at least those that we specified that it should run, that are located in that directory. And I have here pr.yaml. So let's explore, let's see what it does. So we have a name is whatever we want, and then comes one of the most important parts on when it should execute actions, right? It shouldn't run actions whenever we do anything related to a Git repository, but under certain conditions. And in this case, those conditions mean that we should run some actions whenever we do some operation on a pull request. So we are specifying here on pull request, and we want to do it only when pull requests are made against the master branch or the main line, depending on how you define your main line. And then we have a set of jobs. I have only one job here called build, and it will run in Ubuntu. The important thing to note is that the GitHub Actions are always running on top of a VM. They're not running directly in containers, they're not running directly in Kubernetes, they're running on VMs. However, individual steps within an action that is running on top of a VM can be executed either directly on that VM or inside of containers. So what are we going to do? What are the steps? We are going to retrieve the code associated with this action. I mean the code of the repo, the specific branch, and the specific commit in that repo. And we already have a predefined action, which is actions checkout version 2. This is what you are likely going to do within the vast majority of your steps. You're going to go to the GitHub Actions marketplace, you're going to find the step that does what you need it to do, and then just use it. You can, of course, create your own actions, or you can just define actions within the file that are custom to your use cases. But in this case, we are checking out the code using actions checkout. We're specifying some arguments. Submodules, we want to do recursive checkout. And then we are going to set up QEMU or QEMU, I'm not sure how it's pronounced. Anyway, that will allow Docker to build our container images for different architectures. Even though I'm not using it here, I will build container image only for Linux and AMD64. But in your case, you might want to build images for multiple architectures, and then this is very useful. And this is also one of the predefined steps in GitHub Actions. You just search for it and you find it. And then we are setting up Docker buildx. Buildx is the builder that we will use to build our images. Then we are logging into Docker Hub, and then we are building a container image based on Docker file in this repository and pushing that container image to the registry. And some of those steps are using parameters like login action requires username and password so that it knows how to log in to registry and push an image there. And for that, we are using two secrets that I created and you probably, if you're following along, during the setup part of this video. Similarly, we are using parameters to tell build process to push an image and to build it and push it based on specific tag, which in this case is the number of the pull request. Later on, we are creating a cluster. Instead of wasting money to deploy something temporarily in our own cluster, we are going to create a temporary cluster within this VM where Docker Actions are running. And for that, we are going to use K3D. K3D is very fast and very lightweight, so it will work just fine, and it will be lightning fast, so we will hardly even notice the time required to create a cluster. As I said before, if you're not familiar with K3D, you should be, because that's how you should probably run Kubernetes clusters locally and also within pipelines when you need something that is temporary. Finally, we are going to deploy the application. This is the first time that we are not using predefined GitHub Actions or steps within Actions, but creating our own. It continues being based on Ubuntu, and then we are going to execute some shell commands, like we are going to go to this directory, we're going to customize the image used with the manifests, and then we're going to build that using customize. We're going to pass the output to kubectl that will apply those resources to the cluster, to the temporary cluster created with K3D. We're still not using real clusters in any form or way. And then we are going to wait until the deployment is fully up and running by executing kubectl and rollout status. Finally, we are going to execute some tests. These are not going to be real tests. I was too lazy to write real tests. It's more about you understanding how things work than actually really spending too much time creating real tests and real code. So in this example, we're going to simulate tests by sending CURL request or curl request to the application. If it responds with some HTML output, it's working. If it doesn't, it's not. Those are not real tests, but it should be fine for now as a demonstration. Now let's see how all that works. We're going to create a pull request using GitHub CLI GHPR create. Title is going to be, I don't know, my feature, and the body will be read the title. Pull request was created, and I'm going to copy this address and open it in a browser. Here we are. We can see that GitHub Action is already running in that pull request. Let's see the details and see how it's progressing. And right now it is setting build X. It logged into Docker Hub, and it is, what is it doing? I'm not sure. It is building and pushing the image. So this will take a couple of moments. And now that it built and pushed the image, it is creating a temporary cluster inside of that same VM where GitHub Actions are running. And remember, we are using K3D here simply because it's the fastest one and the lightweight one. So let me fast forward until this is finished. Okay, it finished creating a cluster, and now it is deploying the application. Okay, it deployed the application or applied the manifests of the new release or release candidate to be more precise, and it is waiting until it rolls out. There we are, it rolled out, it is about to run the test. There we are, tests was successful, and now it is cleaning up everything. It is destroying all the resources created by this action. If I go back to the PR, we can see that here all checks have passed. We can see those checks. This is the link to the same GitHub action that we already saw. And we can see that everything is successful, not only from GitHub Actions, but also from the pull request. Now we can continue working with this pull request. We can make additional changes to it. And then whenever we change something, another instance of that GitHub action will be executed. We can review the code. We can do whatever we normally do with pull requests. And whenever we make some changes to that pull request, the GitHub action will be executed and it will do whatever it needs to do. Now we can consider what we saw so far as some form of continuous integration. But we don't want continuous integration, we want continuous delivery, which includes continuous integration. And to get to production, we need to merge this pull request to the main line. So let's do that. Let's merge the pull request to the main line. But before we merge anything, let me show you a second pipeline, which is in GitHub workflows and main.yaml, I think, yes. So this is the pipeline that will, or set of actions that will be executed whenever we push some changes. Here we are, push some changes to the branch master in this case. We will run a job called release, and that job will also run in Ubuntu. It will check out the code, it will set up key.mu, it will set up Docker build X, it will build and push container image. Same things as before. Now, the second part is actually different. In the second part, we need to deploy to production, not to a temporary cluster created within that GitHub Actions virtual machine, but to the real production cluster, to our cluster, actually to my cluster in this case. And to deploy to the cluster, we need to set up kubeconfig so that GitHub Actions know how to communicate with that cluster. And for that, I'm using yet another predefined GitHub action, which is k8s set context from Azure itself. And that will create a kubeconfig based on the secret that I created previously during the setup phase called kubeconfig. Now here's a warning, very important warning to all of you wanting to use this. This will work for probably any Kubernetes cluster except AWS, EKS, and GCP, GKE. The reason why it will not work with AWS or Google Cloud is that those two require some custom binaries in kubeconfig. So if you're using either of the two, you should replace this step with steps specific for creating Kubernetes context for EKS or GKE. For any other Kubernetes cluster, at least among those that I know, it should just work as is. Then, once the config is created, we are doing something similar to like before. We're going to customize overlays, but this time to production directory. I'm using customize here. And by the way, if you're not familiar with customize, the link to customize video is up there. Nevertheless, this should work with any way you want to deploy to Kubernetes. You just need to change a few commands over here. So we're doing something similar as before, setting the image to whatever was built in the previous step, and then applying that manifest with the new image tag, and finally waiting until it rolls out in the namespace production. The major difference between this action and the previous action is that this time we are working against the real production cluster and not creating our own cluster using K3D. By the way, now that I mentioned the marketplace a couple of times, let's go to the marketplace and see what we're getting there. Here we are. This is what you get when you go to GitHub Actions Marketplace. Right now, at the time of this recording, there are 8,649 predefined GitHub Actions, some of them made by GitHub itself, most of them made by the community or software vendors of the products that you might be using. Whatever you need is most likely available here. So you can just search for, let's say K3D that I used before. How did I find it? I just searched for it, K3D. And then there are three results, three different predefined actions made by different people, different teams. And I used one of them, I think Abs OSS. Anyways, whatever you need, unless it is very specific to your use case, is already available as an action, and you just find it and then look at the documentation and you know how to use it. They're almost always accompanied by one or a couple of examples that you can just copy and paste and then maybe customize a bit. Now let's see this action in action. That's funny, GitHub action in action. Anyways, let's see how this works. And we're going to do that by merging the pull request. I'm going to do that from the command line because I'm a command line freak. And I already showed you the video about GitHub CLI. So GH-PR merge. And this should actually not yet. I'm going to rebase and merge. And I want to delete the local branch, yes. And I want to submit it, yes. And this just rebased and merged the branch. As a result, we should have an action running right now. Let's check it out. If I go here to the Actions tab, there should be, yes, a silly feature is running right now, and it is performing the action specified in the release job. It is setting up Docker. It is logging into Docker right now. No, it is about to log into Docker. It is building, and soon it will push it, and then it will do the rest. Come on, go. Yes, now it created the kube context. It is deploying the application right now to the production cluster, this time to the real cluster. Let's check out whether it works. Is it already deployed? And to do that, I'm going to find out the address that is used. In my case, is this one. I'm going to open it in browser, and there we go. The application is up and running. It is in production. And the only thing we did was write code and push it to Git repository and merge pull requests. Those are the only manual actions. Everything else was done by GitHub Actions. Now that we experienced hands-on part of GitHub Actions, let's talk about them. Let's talk about pricing and see how expensive or cheap GitHub Actions are. You can choose between a free plan, team plan, and enterprise plan. Free one gives you 2,000 minutes per month, which is 32 build hours per month. That's quite a good number. A team can easily run most of their needs, all of their needs, within those 33 hours a month, assuming that your pipelines do not take hours to execute. If your pipeline takes, let's say, 10 minutes in total, which is neither fast nor slow, that's normal speed, let's say, that would be 2,000 minutes divided by 10, 200 minutes, that would be 200 builds. When we need more, that usually means that we are willing to pay, and then we would go for the team version, which is $4 per user per month, which is quite a good price. I would say that that's a price that hardly any vendor can beat today. And finally, we have some enterprise plans. And I said enterprise. Enterprise is extremely important, but that's slightly more expensive, $21 per user. But all those prices are extremely competitive. So from pricing perspective, GitHub Actions are excellent. Now let's talk about pros and cons. Actually, let's start with cons, the downsides or the things I do not necessarily like with GitHub Actions. The biggest disadvantage of GitHub Actions is that it is GitHub. So if you're not using GitHub, it is pointless to think about GitHub Actions. No, so GitHub Actions are only for GitHub users. If you're in GitLab or Bitbucket or whatever Atlassian calls its Git solution today or anything else, GitHub Actions are not for you. Go away, use something else. Second, events are limited to GitHub events. So you can easily run actions whenever you type a comment somewhere, or whenever you create a pull request, whenever you delete a pull request, when you push something somewhere, and so on and so forth. Even though those might be most common events you will have, they're almost certainly not all the events you have. You might want to run some actions based on some other events. Maybe when you push something to registry, or when you deploy something to Kubernetes cluster, or when something happens with metrics and alert is sent. That could be the biggest downside, is that events triggering GitHub Actions are limited on events created by GitHub repositories, one way or another. Another potential downside is that containers are not really first-class citizens, at least when compared with other similar tools. For example, sharing the state between what's running on a VM and running in containers, and then from one container to another, can be tricky at times. Another thing is that many instructions, many tutorials for GitHub Actions are fostering the idea that you should be building images on top of which your action should be running, and you should be installing tools at runtime, and that's slow. GitHub Actions are not really good at promoting immutable everything. They're not that good at fostering the idea that whatever you need should be pre-built in images and not really built at runtime when actions start running. GitHub Actions Marketplace is absolutely amazing, but it can also produce the feeling of getting lost. It is often hard to find the action that is really good. They have the system of stars, but most of the actions are not really starred, so you cannot use that to decide whether one is better than the other, and then you search for certain type of operation, you find 15 different actions that can help you with that, and you might spend hours trying to deduce which one of the 15 available actions that can help you with certain operations are good. The filtering mechanism, the mechanism that would help you deduce quickly what is a good action and what is an action that somebody created but shouldn't be really used, is challenging. Another thing that I do not like is that only jobs can run in parallel. You cannot define individual steps that would run in parallel with other steps within a job. And that is very limiting. I was often in situations that I had to split what I would normally call a step within a job as a step in a different job, only so that that different job can run in parallel, but then we run into problems of how we share state between those jobs. In any case, parallel execution can be challenging, and it is not necessarily the same level as some other tools we have in the market for accomplishing similar results. The real support for Kubernetes is a missed opportunity. To be honest, I'm surprised that GitHub Actions are not focused more at running everything in Kubernetes. Now, that might not be that important if you're using GitHub Actions as is, if you're not using custom runner in your infrastructure. So if you use completely SaaS version of GitHub Actions, you don't care about that because they're wasting resources, not you. But if you want to run GitHub Actions runner yourself, not running it and leveraging everything that Kubernetes offers is a missed opportunity. I have only one more negative thing to say about GitHub Actions, and that's that environment variables are a mess. Environment variables are the primary way how to pass information from one step to another or one job to another, and how we consume those variables is really messy because it differs depending on the context. It is not the same how we consume those variables from within a VM and then within a container and then sometimes within pre-built actions. You might do a lot of trial and error to see which way of consuming variables or even defining variables works depending on the context. There are also many positive things about GitHub Actions. We can run it as a completely SaaS solution, everything handled by GitHub, or we can run the runner, GitHub Actions runner, in our own infrastructure. And that covers a significant percentage of use cases. We can have it fully managed by GitHub or hybrid solution, or we can even have it completely self-managed if we go with the GitHub Enterprise, and then we get actions with that. And then we have tight integration with GitHub, which can be both good and bad, but it's mostly good because the ability to easily create release notes, to create tags, to do whatever else we do with GitHub is really amazing. And most of the processes related to the life cycle of our applications are tied one way or another with GitHub, assuming that we are not using GitLab or some other alternative Git repository. So the tight integration between source code repository and pipelines, in this case GitHub Actions, is absolutely amazing. And that's probably one of the most important things when we are thinking about CI/CD. How well does it integrate with source code repository, and how well does it integrate with third-party apps? And third-party apps follow the same story. Almost every single vendor has a GitHub action that we can use out of the box like this. All in all, GitHub Actions are excellent for simple workflows. They might not be so good for more complex situations, but if you have more complex situations, then you might start thinking whether the problem is in the complexity of your pipelines or somewhere else. And most of the time it's somewhere else. Pipelines should be orchestrators of your automation, and as such, they shouldn't be really complex. Nevertheless, if you need something really complex like enterprise-grade legacy situation nobody thought about before and we are all going crazy because of it, then GitHub Actions might not be the thing for you. For everybody else, at least among those who are using GitHub, GitHub Actions might be the best CI/CD solution today. GitHub Actions have bad reputation within certain circles, but that's mostly because they were released only a few years ago, I think in 2019. And for a while, GitHub Actions were really bad. It took GitHub time to stabilize it, to build everything that needs to be built. But now, a couple of years later, GitHub Actions are awesome. They're stable, they're simple to use, they're tightly integrated with GitHub, and they're very, very intuitive. All in all, if you're working with open source, GitHub Actions are a no-brainer. I cannot imagine a better solution to manage automated workflows and pipelines for open source projects that are residing in GitHub than GitHub Actions. It's free. GitHub will even give you extra credits if you're open source. There is nothing to manage. For open source projects, GitHub Actions are a no-brainer. If you have open source project, use GitHub Actions. Then we have companies who are looking for fully managed or SaaS solution for pipelines. And for those types of companies, at least those who are already using GitHub Actions, are potentially amazing solutions. So I would really recommend to them as well. Now, for enterprise companies, GitHub Actions could be a good choice, but it could also be a bad choice because GitHub Actions cannot necessarily handle the complexity of legacy systems that we often see in enterprises. Those would be the situations where we have pipelines, let's say running in Jenkins, that have hundreds or thousands of lines of code that describe those pipelines. Complex things that are actually complex because we do not know how to simplify things after 20 years of doing silly stuff. In those cases, GitHub Actions are probably not the right choice.